Okay, now we're going to do a video about when and when not to use the quotient rule. Um, if you ever encounter a function that kind of has a single term denominator, something relatively simple, you can normally avoid the quotient rule. Now, that just depends on how well everything matches up. Um, if you had a function like 2x squared plus 8x minus 7 divided by 5x, you could avoid using the quotient rule altogether right here. Um, Everything kind of matches up with each other. You've got x's, you don't have anything special on top. Everything's in terms of x or a constant. So you're good to avoid using the quotient rule in this case, and I think it makes it a hell of a lot easier. Um, so you just got to break this down in order to use the power rule. Um, I like to think of this as splitting this up immediately into three separate fractions. So I look and I see this right here, which is 2x squared over 5x. And then I see a positive 8x over 5x, so positive 8x over 5x. And then I also see a negative 7 over 5x. Well, we could rewrite this um, and make this just a simple power rule problem, which is what I'm going to do. Um, 2 over 5, excuse me, this would be 2 over 5 times x, because we have a single x underneath an x squared, so that would just make 1x. And then we have a positive 8/5, oops, times 1, so we just leave it as a positive 8/5 because we have an x divided by x. And then we have our negative 7 over 5x, which is just going to end up being negative 7/5 times x to the negative 1. Now, anytime you divide just by an x, it's the negative version of whatever power it has. So if you divide by x to the first, it's the same as multiplying by x to the negative first. And then from here we can just do the power rule, and we would get 2/5 plus 0, because the derivative of 8/5 is 0. And then we would get a positive 7/5. Oh, that's really bad. 7/5 x to the negative 2. Again, our negative exponent is going to multiply down to create a positive value in front, and then we lower our exponent by 1. So this is an answer that we can find in just a couple steps of rewriting, that we don't have to do the quotient rule. Now, if the functions don't match up so well, then we might have to do the quotient rule. But sometimes you can kind of get a little slick and avoid some potential headache. If you see that you can kind of algebraically simplify things to start. If we have a function like this, 2x plus the natural log of x divided by the natural log of x. So the 2x and the natural log of x, they don't really go together. So unfortunately, we're going to have to do the quotient rule at some point. But you could see in this problem that, kind of like on the previous one where we broke it into two fractions, we have this fraction and then we have our other side. The natural log of x over the natural log of x is just 1. So it's going to be helpful for us to think about it in this way to start. And then it's going to make our quotient rule a lot easier later because we don't have this extra term to deal with. So this is the same thing, kind of like what we did in the previous problem, as 2x divided by the natural log of x plus 1. Now this makes things really nice because this plus 1 over here will eventually drop out. So it'll eventually just create a derivative of 0, so we don't even really have to worry about it. What we do have to worry about, however, is this main part here. So we're going to have to do the quotient rule here. Again, 2x and natural log of x don't match. So we are going to call this our high function, and we are going to call this our, wait for it, the ho function, right? Because we learned previously that our derivative, if we wanted to find it, is going to come in this form right here. It's going to be ho times the derivative of the high function less our high function times the derivative of our low function, or our ho function, divided by ho ho, right? So our denominator squared. So we just need to figure out what all of these terms are going to be, and then we just put it together. So we start off, again, we'll start off with our high function. Our high function here is 2x. The derivative of 2x, our d high, is going to be just be 2. Then we are going to go to our ho function. And our ho function is the natural log of x. And the derivative of that, excuse me, d ho, is just 1 over x. Okay, so again, these things just kind of match up together, just kind of like the product rule, because really the quotient rule is just a, funny enough, derivative of the product rule. So the high goes with the d ho, and the ho goes with the d high, just like the product rule. And so we're going to go ahead and put this stuff together to create our derivative. And so we start off with the ho function, which is the natural log of x. We are going to multiply that by our derivative of our top function, which is a positive 2. We then always subtract, it's that less part that you always got to remember, it's ho d high less high d ho. Then from there, we're going to put that with our high function, which is 2x, times our derivative of our bottom function, our d ho, which is 1x. And we divide that by our ho function times itself, which is the natural log of x times the natural log of x. So it's not going to take a whole lot for us to simplify this. We just want to reorder it and clean it up. And by doing that, you would get 2 times the natural log of x. You just always want to make sure that you get your coefficients and everything out front. It just makes things a lot easier to deal with. And then our negative 2x times 1 over x, that's just going to become negative 2. When we multiply by x and then divide by x, it's they cancel each other. So you just end up really just multiplying by 1. So we can just keep this as a 2. And then we divide. We're going to do the natural log of x squared. So the squared, you want to make sure you put brackets because we're not squaring the x. We're squaring the natural log of x. So it's important to write it the right way. But hopefully you can see that because we kind of have this strange matchup of functions in this function, we have a 2x and the natural log of x. That because they don't match up very well, we're going to have to go ahead and do the quotient rule. It's this kind of long drawn out process. It's not so bad. You just have to make sure you remember the formula here, and then you have to identify each part that you plug into the formula. And once you do that, that's the work. You just kind of have to plug it in and just make sure you simplify to make things clean. But that's not always necessary when you're dividing functions. Sometimes you can think about these in different ways. You can break them apart. Anytime you can break it apart, it's a great thing to do. Most of the time that's going to happen when you have a single term in the denominator, and more specifically when that single term works with the other terms in our numerator.